In this problem, we're given 3 voltages, 3 currents in a table. We need to find the missing values. Sometimes we're given amplitude, sometimes we're given peak-to-peak value, and sometimes we're given root mean squared value, but we got to find the missing ones. So we're going to start this off by looking at how this works. We have some kind of sinusoidal wave, something that'll go like this. And the amplitude is going to be from this value to this value. This is the amplitude. Same thing for here, this value to this value. And the peak to peak value is going to be from here and here. So this is peak to peak, and it's basically amplitude times 2. Now the root mean squared is in the notes linked below the like button, but the formula for this is that we are going to have some V RMS, and this is going to be equal to the Vmax divided by the square root of 2. Now if we are given our VRMX and we want to find our Vmax, our Vmax is the amplitude. We can see that it is the maximum value here. So we can kind of substitute this in for an amplitude. So we can rewrite this as VRMS is equal to the amplitude that we were given divided by the square root of 2. And if we wanted to find the amplitude, we can use the equation where we have the square root of 2 times our VRMS, and this is equal to A. And this is just through simple manipulation of the first formula. So these are the equations that we're going to use along with the graph to solve this. So looking at the first part, we have the amplitude 1.414 volts. We know the peak to peak value is equal to the amplitude times 2. I wrote that down right here. So if we do this, we are going to get a voltage of 2.828 volts. Now we need to find the root mean squared, and we're just going to plug in the amplitude. We're going to have 1.414 divided by the square root of 2, and this is going to give us a root mean squared of approximately 0.999, and this is going to be measured in volts. We could also say that this is 999 and it's in millivolts. For the next one, we are given the peak to peak value. We know that the amplitude is just going to be half of this, so we can say that this is 1.000 volts. And then the root mean squared of this, we just need the amplitude divided by square root of 2, so we're just going to have 1 divided by the square root of 2, and this is going to give us approximately 0.707, and this is measured in volts. Equally, we can say that this is 707 millivolts. Next, we are given 300 millivolts for our root mean squared, so we're just going to find the amplitude. We are going to have the square root of 2 be multiplied by 300, and this is going to give us 424. Remember, this is still in millivolts, so when we write this out, it's going to be 424 millivolts. Now to find the peak to peak, we are just going to multiply this by 2, and this is going to give us approximately 849 millivolts. Both these answers are rounded, so it's not exact. Again, rounding is what we did here to get these values. Now we're looking at current, so the lower half of the table. We are given the amplitude for this, so now we need to find the peak to peak value. It's going to be the same exact formula as we used for the voltage, so we're just going to multiply this by 2. This is going to give us approximately 0.200 amps. And now for our root mean squared, it's the same equation. V RMS is equal to I RMS, and we can write that here. It's equal to I RMS. So when we plug this in, we're just going to have 0.1 divided by the square root of 2, and this is going to give us approximately 0.0701 amps, and that is our root mean squared. Next, we're given the peak to peak, and the amplitude of this is just half of peak to peak, so we're going to have 150 amps. And to find the root mean squared of it, we're going to take our amperage and divide it by the square root of 2. This will give us approximately 106 milliamps. And now we look at the last one. For the last one, we have 4.242 amps, and this is for the root mean squared. So we want to find the amplitude. We're going to have 4.242 times the square root of 2, and this will give us approximately 5.9999. So that's the answer for that. Now the peak to peak is just going to be this multiplied by 2, and that's going to give us approximately 11 0.99, and this is in milliamps. So that is how you would go about filling in the missing values.